Hi everyone and welcome to the Full Stack Roadmap. This is going to be a long video, but a very important one if you're thinking of becoming an open source contributor, if you're thinking of cracking Google Summer of Code this year, or generally if you're thinking of contributing to open source companies or getting into remote jobs, or even if you're thinking of cracking a few startups, India or abroad. Full stack development is an extremely underrated skill. It is a skill that's used all across the industry. It doesn't matter if you're doing a basic backend job, a front-end job, if you're working even in machine learning, AI, or Web3, there are certain components of your job which require building a front-end or a backend or a basic system that people can use to interact with your more important, bigger system. For example, in the Web3 world, if you have a smart contract out there, most probably there will be a front end that will interact with it. And most probably you might also have a centralized backend where you're storing your user data. What this means is full stack development is a skill that can be used all across and is usually the first step when you're trying to become a software developer. It also gives you an idea around how websites work, how mobile apps work, and how in the real world applications are built. As always in my roadmaps, this video will have an assignment in the end, and the people who will be able to do the assignment will be able to join the internal Discord group that we have, which is a group of extremely competent and self-dependent software developers who do assignments every time I give them, where we talk amongst ourselves, and if people have questions, they ask each other. It's a very elite group of people, and whenever I come across any remote opportunity, I tend to refer people from that closed group because I know these are people who are very obedient, confident, and also smart at doing things and figuring things out on their own. This video will be broken down into various sections. The whole full stack development series would be a series of 3 videos. This is the first one in which we'll be tackling backend development. I'll quickly share why. In the second one, we'll be tackling front-end development, and in the third one, we'll be doing some advanced front-end and backend so that we start from the basics and we move to an advanced concept. After the third video, you should basically be able to target as many open source companies as you want because most companies have stacks similar to what we'll be discussing in this video. The first part of the video, as usual, will be piquing interest in this video in backend development. What backend development is, what a backend developer does on a day-to-day basis, what are the systems that you build, what is the jargon that's used in the industry that might confuse you, and what you have to do on a day-to-day basis when your responsibility is that of a backend developer. In the second part of the video will actually be coding stuff, making the backend of a website and deploying it somewhere so that you guys can interact with it. In the end, I'll be open sourcing a repo which will have some portion of what we'll build today and a bunch of tests. You can fork that repo, complete the assignment, make sure all the tests pass, and then feel free to create a merge request. I will not be able to merge all of them, but I will merge one at the very end, and that might give you your first open source contribution. More importantly though, after this video, you should be able to at least understand a bunch of open source repositories and a bunch of open source programs that are out there. And slowly and steadily, I think by the end of the third video, you should have enough knowledge or at least know what to do when you're trying to tackle an open source code base. After the third video, I will be picking up open source projects and contributing to them one by one. I wanted to start contributing to open source projects right away, but I realized there's maybe a skill set that's missing from people, and people need to understand full stack development before they can start contributing completely. So this series, a 3-part video, is going to help you achieve that. And once you do that, we'll be contributing to actual open source projects out there. Full stack development is all I did for the first 3 to 4 years of my job. My first job being a Goldman Sachs engineer. I worked there and had a 30 LPA package. My second job being freelancing on Upwork, and I made 30 lakhs on Upwork in around 3 months. Here's the video if you haven't checked that out. And then I got my first 100K offer, which was also pure front-end and back-end development, which means full stack. After my third job, I went a little bit into deep tech and a little bit into Web3, and that's what I do now. But the point here is, with full stack development, you have enough skills to crack at least a 100K offer, which is a good starting point for you from India. And from there, you can decide whether you want to stick to full stack development or build some more advanced things, get into more niche fields and decide what field you want to go to. But the first step is always full stack development, and that's what we'll be tackling in this series. With all of that context, let's get right into the video and understand the jargon that's used in the industry when doing backend development. So we're at the board now, and I'll try to explain 5 concepts that are very important or jargon that's used in the industry that might overwhelm you if this is the first time you're trying backend development. I'll try to explain it in very simple fashion, and then in the next part of the video, we'll actually be coding it. So The very first jargon, and you guys might have heard about this if you're doing computer networks back in college, is called communication protocols. Before I get into it, can someone tell me in the comments what communication protocols are? 5, 4, 3, 2, 1. Okay, I hope you got it. But communication protocols are basically a way, and I'm going to teach this from the very top because this deserves a course on its own on computer networks. But the knowledge that you need for full stack development, I'll try to stick to that. So communication protocols or protocols in general, the word basically means this is a protocol that needs to be followed for doing some task. For example, when you're in a military, I'm assuming when you're in the army, there are certain protocols when someone, let's say, attacks a building, or whenever there is some sort of an attack somewhere, the military has to follow a certain protocol. That's where the word comes from. And more specifically, communication protocols usually mean a way or a protocol for systems to follow when they want to talk to each other. So back in 1970s, 1960s, people had these computers, but they couldn't really talk to each other. Eventually, people realized if you connect them with wires, they can actually talk to each other. And if you think about it deeply, full stack development, or more specifically backend, what we're discussing in this video, is nothing but computers talking to each other. I'll explain this better a little bit more. But before we get there, systems need to talk to each other for anything to happen. For example, when you're on what's a famous website today? Instagram.com. When you go to this website, and let's say you're at the login page, when you put your username and password here and press the submit button, a request goes out to an Instagram backend server. Hence, your machine is effectively communicating with an Instagram machine somewhere out in the world. These wires there's a very big web of wires all across. You might see a wire come out of your modem. This wire goes to another modem, and then from there a bunch of routers are connected, through which you basically talk to machines. These machines have something called as addresses, but we won't get into that just yet. What you need to know is machines need to talk to each other, and there needs to be a specific defined way around how they should talk to each other. Else, this machine will try to send something to this machine, but this machine won't understand it. So a protocol effectively is a way for machines to talk to each other. It's a defined set of rules that machines need to follow when they're talking to each other. Now, there are more concepts here. For example, there are application level protocols, and then there are more lower level protocols. I think that's the right trajectory, but we will be only discussing two types in this video. Let me clean this up. The two types of protocols we're discussing are called transport layer protocols and application layer protocols. There are a bunch of other protocols in between, but we'll only be discussing these two because these are sort of important. The two famous transport layer protocols are TCP and UDP. And application layer includes a lot of protocols, important one for us being HTTP, which stands for Hypertext Transfer Protocol, not that it matters. These are two protocols that machines use to talk to each other. This you should Google and understand what this is. From the very high level, TCP was built so that when a machine tries to talk to another machine, if there is ever a network discrepancy here, the machine will retry and keep sending the messages until it is able to create a connection. But UDP will just throw messages or packets at the other machine, and if the other machine does not accept it, there's basically no acknowledgement needed from the other server to tell the original server that I've received this message. So UDP is usually used in things like live streaming video. When you're receiving video, when you're doing a Zoom call, even if you miss a few packets from the other side, it doesn't matter. There's no point for you to re-ask for those packets, because if you re-ask for packet 1, by the time it comes back, that time has gone. It's really back in time, and you really don't want those frames that get missed. So when you're talking to someone on a video call, or if you're watching the cricket match, let's say, Usually, a UDP based protocol is used so that even if packets get missed, you don't worry about them. You just skip them. There's a small black frame which you don't worry about, and the video keeps going from there. But in more important things, for example, the Instagram example that we just discussed, where you have an input box and you click the submit button, this request needs to go via TCP, because if there is a network disconnection, you want to retry this request. This is an important request. Only if this request reaches the server and responds with something will you log in. So this needs to be based on TCP. These are lower level protocols, and usually when you're writing a full stack app or a backend app, you don't have to worry about them unless you are building a video streaming application. Application layer protocols, as the name says, is what an application developer, which is you when you're building a backend application, needs to worry about. So this is basically the most important thing here. You need to understand what HTTP is. You actually don't even need to understand it. You just need to know this is a communication protocol that browsers use to interact with servers. There are other protocols that are also used, but for the scope of this video, only the first video, we'll be focusing on HTTP. What will happen in the end is we will be building an HTTP server, very similar to Instagram, and we'll try to send some requests from our browser to this HTTP server. So you'll be able to see that request actually go out. You'll be able to see that this is an HTTP request, and you'll be able to see on the server, or when we're writing the code, you'll realize that what we're writing is an HTTP server. We won't be writing an HTTP server from scratch. Whenever you're using a backend language, most of the times, an HTTP server is a very popular use case. So there are frameworks or libraries out there that let you create HTTP servers in a few lines of code. We will be using one such library. But if you want, this is a great assignment. This is the first assignment that I did when I joined a lab back in college. I wrote an HTTP server from scratch in C++. Take it as an assignment, although if you're a complete beginner, I would suggest you first complete this video and then try to create an HTTP server in the language of your choice. With that, let's move to the second thing. After communication protocols, the second important thing is databases. Now, what is a database? I think most of you might have heard of things like MySQL, Postgres, or MongoDB, maybe something like Firebase as well. These are all what are called databases. They're usually represented like this in application diagrams. And what they are basically, if you remember, we have the front end, which sends a request to the backend. Now the backend is like a process running on a server, and these servers are sometimes small, sometimes big. These servers can go down, and hence you don't want to store data here. What is data? If you're accessing Instagram.com, then it's your user data, your username, password, everything is sort of stored somewhere, which usually is a database. Now, there are popular databases that basically make it easier for you to query and write data to a database. These are the ones that are usually used. What we'll be using in this video would be Postgres. And the purpose of this database, is to store data. There are ways to scale these very independent to how you scale an HTTP server. But effectively, this is your browser. This is an HTTP server, what we discussed in the last part. And this is a database. All three things are very important to build a full stack application. These are usually enough to build a simple application, which is what we'll be building in this video. But eventually, when you're building bigger systems, you need some more jazz, which I'll discuss in this video, but we won't code. We will be coding this in the third part of this series, but I'll still discuss it. So up until this point, we understand browsers, we understand HTTP servers, and we understand databases. Again, we'll be coding this very soon. But before we do that, let me teach a few more things so that you have a basic overview of how an application like Instagram would work. The fourth thing that I wanted to discuss here are messaging buses, or what are called pub subs. So up until this point, to build a very basic application, for example, an application that has basic authentication, you can hit an HTTP server, which will talk to a database, verify that the username and password is right. Basically, what it'll do is it'll ask the database maybe for the user that has this username and their password, and then it will match the password that you sent to the password that it got from the database. And if that's true, it will return you a response that says, hey, everything looks good. Else it will return you a response that things are bad, please retry. But more complicated applications, for example, in Instagram, once you've logged in, maybe you need to send an alert to the email or the phone number of this user that says, hey, you logged in from New Delhi, India. Are you sure this is you? If not, then please click here. So this is a common use case when you're trying to log into a system from a new location. And to build this, usually these things are not enough. The three things we've discussed until this point, they can be used, but a better thing to use here are asynchronous communication systems like message buses and pub subs. So let's try to understand what they are. Here you sent a request to the HTTP server which logged you in. Now the HTTP server needs to send a request to basically your email and your phone number maybe. And these are sort of, how do I say this? These are processes that you worry about, but you don't worry about them immediately. You might have noticed when you're doing a Google Pay transaction, you see the transaction feedback immediately on the app, but you get a message from your bank in like 5 to 6 seconds. The reason for that is these are not important events. Like they're important, but they're not immediately important. Logging the user in is immediately important. That's the feedback they need to see here on the browser. But the email can reach them in like 5 to 10 seconds. So you offload these tasks that are sort of important, need to reach the end user, but maybe in a while, to usually other backend processes in your system. And these backend processes are also machines that you have somewhere on the internet. And now these machines need to talk not to the browser, but to your backend service. Let me clean this up a little. So your front end sent a request to your backend, and your backend now basically needs to send another request to your email server, which has the responsibility of emailing the other user, and your phone number server, which has the responsibility of text messaging them. Why do you not do the same things here? Because this is a backend server that's needed for immediate requests. It needs to handle a bunch of other requests. If you could do that here, but that's what's called a monolith architecture, and as the name suggests, it feels bad or sounds weird. What we're doing here is a microservices based architecture, which means there are different services that do different tasks, and specifically tasks like sending an email and sending a phone number, which are very asynchronous tasks, can happen in their own time, usually make sense to be separate processes or separate services. So this backend server now needs to tell the email server to send an email and the phone number server to send to call another phone number. Problem is, if you make these HTTP requests, just like this one is, you could make them HTTP requests, but HTTP requests require a response right then and there. The backend server will basically send this request and wait for the response from the email server. And sending an email is a tough task. It's a longer task. You have to maybe hit another external service which will send the email and then wait for acknowledgement. And same for phone number. So effectively, you're blocking the backend server for these tasks to complete, which is bad. As I said earlier, these are not tasks that need to happen immediately. So what you can do is, rather than directly talking to the HTTP server, and then another downside here is, if your email server is ever down, the backend server will try to send a request and it's down, this will get missed, and this message will never reach the user because your email service was down when your backend tried to talk to it. This is where very nice internal communication systems like messaging buses are introduced. As the name suggests, a messaging bus is like a messaging queue where you have a server which contains what looks like a queue, and your backend server can simply put a message in this queue, and the email server and phone number server can keep picking up messages from this queue. Why is this better from a direct HTTP call? As I mentioned earlier, if this is down or this is down, the HTTP request will fail and it's gone forever. But if you put this thing inside the messaging queue, even if the email server is down right now, it will eventually come back up, and when it does, it will pick these messages and send out the email. As I said, email doesn't need to happen immediately. It can happen in like a minute, 2 minutes, just to let the user know that someone has logged in. So even if your email server is down for whatever reason, whenever it comes back up, it can pick the message from here. Now you might ask, what if the messaging server is down? If the messaging server is down, then you're pretty much fucked. You have to make sure that this is either reliable, or when this goes down, the backend server basically either invalidates this request or stores in the database that, hey, this message got missed, and then maybe sends it in the future. But usually the idea is that these things auto scale and these things are transitory, can go up and down, can even go down forever and then come back in an hour. But the messaging bus needs to be reliable. If it's not reliable, then yeah, you're pretty much fucked and you'll miss out events. There are other ways to optimize this further, but this is a good enough system for you to understand how asynchronous tasks happen at the backend. This is one asynchronous task. There are a bunch of other things that happen when systems try to communicate with each other. And usually on the backend, when you're sending an HTTP request, a lot of things happen. Things like logging, things like authentication. A lot of times your backend server is not doing authentication. You have an auth server sitting in front of the backend server. And you sometimes even have a load balancer. So effectively, there are a lot of backend services that are running, even though in this video, we'll only be creating a single HTTP server. Eventually, in the third video, we'll create these asynchronous systems that will be able to talk to each other in the backend. So up until this point, we understand HTTP servers, communication protocols, an HTTP request that goes to a server via TCP. The server maybe does a query to the database and sends a message to a messaging queue, which then forwards it to other services which do their own thing. If you have any questions up until this point, let me know in the comments and I'll try to respond to it. This is a very nice basic architecture for the backend of an application. And from here, let's actually start coding this. To create a very simple system, let me describe what we're building now. The longer term assignment that we're building in this video is that we're building LeetCode. If you guys haven't seen it, LeetCode is effectively a platform where you can go and solve algorithmic problems. The interface looks very similar to any other application. You can log in, sign up. Once you sign up, you see a bunch of problems. Once you click on a problem, you see the problem statement on the left. You see a text area on the right where you can solve the problem, and you see a submit button. When you click the submit button, a request goes to a backend. The backend processes whether or not your request was right, and then lets you know whether your submission was accepted or rejected. This was an application that me and a bunch of friends built back in college. It was called Code Village. It was very similar to Code Chef or Code Forces, where you could conduct contests. We won't be conducting contests. We'll build a simple website which will show you a bunch of problems. And when you click on a problem, it will take you to the problems page. You can see the problem here, the code here, and a bunch of buttons here. Once you click on these buttons, it will let you know whether or not your submission was accepted or rejected. But this is the first part of the series. In the first part, we're just building the backend. And hence, what we have to do now is create an HTTP server, the thing that we just discussed, which will do a few things, which in the next video, we will connect to the front end so that the front end can send requests to the backend. So let's try to understand what like a simple LeetCode application looks like. This is the landing page. You have a login button here and a sign up button here. So two functionalities that you need to build in your system are: one, login; two, sign up. There may be something else like reset password, but let's not do that. Let's leave that as an assignment. So backend needs to do these things, and it also needs to, when the user is creating it themselves, it needs to basically give them roles, either a user or an admin. Why an admin? Because later on, the admin will have authority to create problems here. So another endpoint would be an endpoint to create a new problem. This endpoint should basically check and make sure only admins are allowed to create a new problem. And finally, we will create sort of a dummy endpoint that will accept the input from a user when they click on submit. So basically, submit problem. I said this will be a dummy endpoint for this video because when you click on submit, this code that you've written goes out to a backend service which basically has to run your code there, which is sort of a complicated process and an asynchronous process, which we will discuss in the third video. If you want to do it yourself, I would highly recommend use something like either Redis queues or RabbitMQ. To do this yourself, you will also have to Dockerize stuff. I'm saying a few things and leaving them as an assignment. If you want to do it, great. If not, we will get to it in the third video. But in this video, we'll be doing 4 things. Login, sign up, create a new problem, and submit a new problem. And I'll be leaving a few assignments for you to try out as well. Again, we're only building the backend, not building too much of the front end in this video. In the next video, we'll build actual front ends. This video will build like a basic front end that lets you do these things with HTML, CSS, and JavaScript. The tech stack we're using in this video is the very famous MERN stack. Why? It's very popular, used all across, and the language we're using is JavaScript for now, but eventually we will be moving to TypeScript. But for now, we're using JavaScript to build a full stack application similar to LeetCode in 3 videos. The first video being you building this backend and a very basic front end. If you can do this yourself, or if you want to do this yourself, ChatGPT can help you out. The only questions you need to ask ChatGPT are, how can I create a basic login sign-up system using the Express framework in Node.js? And here, the second question you need to ask is, how can I create a post HTTP request to accept a new problem? What are the arguments that you'll need there? You will need just the problem statement for now. You will need test cases as well, but let's ignore that for now, just so that we don't worry about the application level jargon. So the creator of the problem needs to submit a title for the problem and the problem statement. Maybe a test case, which is something you see here in LeetCode, where you have the inputs. Hey, the input should look like this and the output should look like this. Test case, but this is an array, this is a string, and this is also a string. And finally, submit a problem is a dummy endpoint, which should accept the ID for the problem that the user is trying to submit and the code that they've written here. Cool. Hopefully, you can do it yourself. If not, we'll be tackling this in the second part of the video. So let's get right into it and let's start coding. So before we get into coding, I need to share some more things, some specifics around the HTTP protocol that I just told you about. As I said, we in the end need to make an HTTP server that you see here on the right, and our browser is what will interact with the HTTP server. If you actually look at any website, for example, Facebook, Instagram, or even ChatGPT, these are all running on some HTTP server and returning you some data from an HTTP server. Just to show you that example, if I right click here and click on inspect, this Chrome developer tool thingy opens up. If I go to network, this will show me all the network requests that are going out from my browser to ChatGPT as I navigate through the application. So ChatGPT also has an HTTP server, and my browser here, which is this figure right here, is sending it some requests. And just to understand the structure of that request, let's refresh this page and see what's going out. So if I refresh this page, as you can see, a bunch of these requests went out. Now, some of these are return simple HTML. For example, the first request that goes to exactly this URL, chat.openai.com/chat, actually returns you some HTML, and your browser is smart enough to know this is HTML and it renders the page over here. But all the other requests that are going out, some of these are like script tags, things we'll ignore for now. But the important ones here are, this is a request that goes to chat.openai.com/API/auth/session. And most probably it returns me my details for this auth session. Please ignore the access token here. This will give you access to my ChatGPT account, which is bad. But as you can see, it's showing me the details, my email, my photo, things like that. And there are a bunch of other requests. For example, conversations. This is giving me all my existing conversations. So I've talked to ChatGPT once before this. As you can see, that conversation is right here. The title of that conversation is No History Snooping, and you can see it right here. So effectively, the first request goes out and gives you all the HTML to render this page. And then there are a bunch of subsequent requests that give you things like, hey, what was this person's chat history? The reason all of them don't come at once is to decrease the response time so that the user gets something. If I refresh this page, I see something as some initial feedback, and then eventually this thing comes up. So there are multiple requests that are slowly going out. Now, let's try to understand the structure of such an HTTP request. So when you're sending some requests, you will send one, the URL that you're trying to access, basically the URL of the HTTP server. There are more complicated things, but just for simplification right now, you have to identify and give out the URL of the HTTP server. When you're going to facebook.com or instagram.com, you're basically doing the same. Facebook.com is the URL. Here, chat.openai.com/chat is the URL. And for the other request that I showed you that's getting my conversation, the URL is chat.openai.com/backend-api/conversation offset equal to 0 and limit equal to 20. So this whole thing is the URL. You change the URL. These things at the back are called routes. So /backend-api/conversations is a route. So chat.openai.com is the URL. This thing you see here is the route. And then offset and limit are something called as query parameters. So let's go back to this diagram. You have to specify the URL. I would actually break this into two parts. You have to specify the URL and the route, and you have to specify, you can specify a bunch of other things. The second thing is the type of the request. So there are a few types of requests. Important ones for now are get, put, and post. Get request you send when you want some data from the server. Post request you send when you want to send some data to the server. And put is when you want to send data, but not exactly add a new thing, but update a new thing. So practically, when I want to get these conversations, I will send out a get request. So if you look at this conversation request, as you can see, it says get here. But if I want to actually add something new there, then I will send a post request. So if I add a message here, hi, can you tell me something? And I press enter, the request that will go out will be a post request. If there is a request, there could be cases where requests don't go out. But here, as you can see, this is a post request that went out. And if you look at the payload, it is showing you the message that I sent, which is this thing. Hi, can you tell me something? And this that you see here is the payload. So there is a URL, there's the route, there is the type of the request, get, put, and post. And then there are these things on the right, which is the payload that you're sending, meaning data. You want to tell the server, hey, do something. The route will tell the server, okay, this person wants to do something here, but you need to pass in some data as well. And data can be classified into various things. The first one is headers. Headers are basically a way for you to tell the server some auxiliary information. For example, your cookies are usually there, your browser information is there, the site that you're sending request from, which in this case is this, is there. So a bunch of auxiliary information, which isn't the actual data that the server needs, is sent here. As you can see, there is a request. These are the response headers, but there is a request headers section that is sending my data to chat.openai.com. And these are the request parameters that are going. The authorization header is an important one here. I'm not showing the whole thing, but this long string is what I sent to the chat.openai server. And they know this is me. This is like a cookie, if you've heard of it, or like some sort of a password. So every request that I'm sending out, I send this cookie along with it. In this case, it's not a cookie, it's an authorization header. But this authorization header is what tells the ChatGPT servers, this is Harkirat. And these are like stored somewhere in your browser the first time you log into the browser. So when you log into chat.openai.com, if I open this in incognito window, you see this. And when you log in, you send a request to the server, a post request to log in, sending your email and password that I put here. If I put my email and password and click on continue, I send a post request and the server returns an authorization header, which I store in my browser. And in every subsequent requests from this page after I've logged in, I send that authorization header. We will be implementing this very soon. But just for you to understand, this authorization header is very important amongst all the things that you see here. Cool. So these were headers. Then there is something called query params. Query params are effectively query parameters, which over here is offset equal to 0 and limit equal to 0. So this offset equal to 0 and limit equal to 0 is a way for me to tell something to the server. Usually when you're sending out GET requests, this is the way for you to pass data to the backend. There is no easier way to pass the data because if I open this in a new tab here, as you can see, it says authorization token is missing. But when I'm sending out this request, a response is coming back and I'm sending in that request, hey, limit is 20, which means I need 20 records at max from my history here. And offset is 0, which means I need the first 20. We'll explain this later on, or go to ChatGPT and understand pagination. But that's what's happening here in this request. And these things I'm sending there are query parameters. The next thing is body. The body is another way for you to send data. So you could either send it via query params that we just saw, or you could use the body. For example, if I send a new message here, hi there, I press enter. As you can see here, the post request that I send has some payload in there. The input being hi there, or like I have a typo there, but you get the idea. This data that I'm sending is the body. And usually when you're sending post requests, you send data like this inside the body. This might feel weird to some people. This is like a key value pair or a JavaScript object or what's called a JSON. and you're sending some data here. So this is similar to, we sent data here as well, but this was a GET request. So we sent them in the query parameter, and this was a POST request. So we sent them in the body. Cool. There is also one more thing called cookies, which we will discuss later. For now, this is used for authentication, but for now we will use the authorization header for authentication. So we should be good to go, and we need not worry about cookies just at the moment. Now you send the request. The sending structure looks like this, and we will be implementing this very soon on the HTTP server. The server needs to respond back, and the server also gets to send back some data. The important data it sends is response headers. So as you saw earlier, it can also respond with some headers, and these are usually used for sending things like cookies, and that's probably the most important use case. Other than that, you don't usually worry about the response headers. It can also send you a body, which could either be text, JSON, or HTML. Yeah, so if I go to chat.openai.com, so here what I'm getting back is JSON, and here the original request that goes out. So there are a bunch of requests, but the first request that goes out returns me. So if I go here, you can see when I refresh, the first request that goes out returns me HTML. So the server could return you various data shapes, and usually these are the common ones. One more important thing the server returns you is status codes. These are slightly complicated, but the idea is this is a way for your server to let the client know the operation that happened on the server. So you might have heard 404 very commonly. 404 usually means this resource isn't present on the server. Every status code means something. 200 and 201 usually means things are good and you got back good response. But if something goes wrong on the server, for example, if you don't have authorization to use a page, your backend server should ideally return 403 so that whoever is sending the request knows that 403. So if I search for what does 403 status code stand for, it will tell me it means forbidden response, which means you are not entitled to this resource that you're trying to access. When I'm trying to send a request here from my browser without the authorization header, as you can see, the status code I got back was 401. 401 and 403 usually both mean that you don't have access to this resource. There are a bunch of status codes, all mean a lot of things. We don't have to worry about them yet. But the important ones you need to remember are either 200 or 401, 403 or 404. These are the important ones your server should return when you either have a good response to return or a bad response. And that's more or less it. This bubble basically contains the request lifecycle of when you send out an HTTP request and what comes back. Now let's actually start writing an HTTP server. You can write an HTTP server in any language of your choice. We are using the MERN stack and hence we will be writing it in Node.js. Some JavaScript prerequisites are good to know. For example, you should know how to write for loops, while loops, general basic stuff. But other than that, we will be using libraries to create the HTTP server. So the HTTP protocol is like a very famous protocol that you can write on your own, but usually in every language, they create some very nice libraries that make it very easy for you to use those libraries to create HTTP servers, because the use case is very common, right? You understand an HTTP server needs to accept a route, a URL, the type of the request, and a bunch of these things. And you know, it needs to respond back with some things. So all languages have created abstractions. There are very famous libraries out there. The one we are working with today is Node.js, the language, and JavaScript, the language, Node.js, the runtime, and Express, the framework. In MERN, E stands for Express, and Express is a library that lets you easily create HTTP servers. If I go to this page, you should probably be able to see a very simple boilerplate code. Let's see the Hello World program. It looks something like this. As you can see, we will code this from scratch, but very simply, this is the way to create a GET route. So app.get means we're creating a request handler, a GET request handler on the /route, and we're sending back simple text hello world. So let's now start coding and write a simple HTTP server and go from there. Cool. So the first thing you need to do is install Node.js. There are multiple ways of doing this. I am going to ask ChatGPT. You should too, based on your operating system. Might be slightly difficult on Windows, but fairly simple on Mac and a Linux-based machine. So let me search how to install Node.js on Mac. I already have Node.js, so I don't have to do this, but I'm still doing this so that I can show you guys. You should also understand terminals, what terminals are. The Mac has a standard terminal. If you search for terminal, you'll see one here. You can install more complicated ones. I usually use iterm these days. This is a terminal. You can basically run the same commands here. If you're on Windows, you will have the command prompt that will let you do these things. You should ideally move to WSL on Windows, and even more preferably use some version of Linux. It will make your life much easier if you're starting off seriously contributing or like seriously starting development. Linux based machines or even Mac works very fine. So I would strongly suggest you do that. So here, as you can see, ChatGPT tells us, hey, you can use the official installer. And once the installation is complete, open the terminal and verify the installation by typing these two things. So this is important. For me, it's simply brew install node and that should do it. So I'm not going to do it, but if I press enter here, it should install node. I already have it. So if I search for node space -v, it's giving me the node version I have, which is 18.1.0. And if I search for npm version that I have, it says this. What is npm? So usually whenever you have a library, you have a runtime and a package manager. As I told you right now, we'll be using Express, and Express is effectively a package that's deployed on the internet and anyone can use it. Package managers make your life easy to get these dependencies from the internet and then host them on your repository. So if your repo moves from one server to the other, you have like a package file which contains all of your packages and you can install it. So package managers are very important and most backend languages have them. For Node specifically, the package manager is called npm. And if I search for npm space -- help, it'll give me all the commands that I can run here. Okay. We are now getting right into writing our first HTTP server using Express in Node.js. So if someone tells you create an HTTP server for me in Express or create the backend for a MERN stack application, these are the steps you need to follow. What is that application that we're building? We're building LeetCode, the backend of LeetCode, but more specifically in this video, we're building the basic authentication system. So someone can log in into their profile by sending username and password, even sign up, first sign up, send a username and password. Once you've signed up, you can log in. Once you log in, you get back a token from the server that you can use to reinitiate logins to the server. Cool. So let's start by creating a new directory, mkdir express backend app. If I go here, the next thing I have to do is call npm init. What this will do is create a file. If I keep pressing enter here, by the end of it, I will see a new file here called package.json. This is a very important file, usually the first input file of your Node project. It provides Node.js, the runtime, a bunch of information about your project. So the key things here are the name of your project, the version you are on, description, the main file that should run in this project, a bunch of scripts, and you can actually change this. Let me edit this and add a few more things here. Let's add start node index.js. I just want to show that you can actually change this file. It doesn't need to be the same and you can like feel free to edit it, and the author and the license. So this is a very basic file. We will add more things to it. But as you might remember, the file has this main file written here. So let's also create a main file. You can do that by calling v-main.js to open it. So feel free to use an editor of your choice. I will use WebStorm. You can use VS Code, which is very famous and a lot of beginner people use that. I'm using WebStorm because I'm more comfortable with it. So as you can see, I have two files, package.json and index.js that I just created. Now, let's just copy the boilerplate code here. The getting started, hello world. This was the code. Let's copy it here, paste it here, and try to analyze what's happening. We at the top are importing this Express project. What is Express? As I said, it is an HTTP server that a lot of smart people have written that you can reuse and just call a bunch of functions on to create an HTTP server. So we import that at the very top. We create an instance of that. So this is a very Express specific detail, will be different for different HTTP servers. In Express, you create an app object by calling the Express function. You have to specify a port. Now, one thing I did not tell you here, I said that the URL basically looks something like chat.openai.com, and then you give a route. You can / should also give a port. When apps are usually deployed on the internet, they're deployed on specific ports, which is why you don't see them here. But a lot of times you might have to go to chat.openai.com, 899999000. This port is also an identifier. You can think of it as a part of the URL for now, but it is an important detail. And when you're especially working locally and creating a backend server locally, you need to specify a port where your application will run, and very soon I'll show you where this is actually used. They have also defined a single route here, a route being, as I said, the part of the URL. So the route is /, which means if you send a request to /, which if the URL was chat.openai.com, it would be something like this. The route is /, which means there's basically no route. Then send hello world, the text. So if I go to chat.openai.com, and the chat.openai.com looks like an HTTP server that looks like this. It will return me back hello world. And this line is again a detail for Express where you have to call app.listen, which will actually start your HTTP server. Up until this point, if I just run this much code, nothing will happen. The HTTP server won't start. I've just given it a route. Again, I can give it like multiple routes, but for now I just have one. And if I write app.listen, it will actually start the HTTP server. And when it starts, it will log this. I feel at this point, this tutorial isn't very beginner friendly. Let me change a few things here to make it slightly beginner friendly, but you will need to understand JavaScript before you dive into Express is what I feel. So if you don't know JavaScript up until this point, do a bunch of basic tutorials so you understand JS and then come back to an implementation detail. I've said this in the past. It's very hard to do two very hard things at the same time. First, tackle one. So if you don't know JavaScript yet, first tackle that and then come back here. You might be slightly, if you've worked with other languages, this might feel very weird. Why are we sending a function as the second argument? So that is again a JavaScript specific detail. Do that first. I'm not sharing that here, but first do that and then come back to the video. If you already understand this, great. Let's try to run this file. So the file is called index.js and I can just run node index.js. When I run it, I get an error, and the error, it says cannot find module express. So I have imported Express at the top, but I never really added it to my project. As I told you, our project can actually contain a bunch of these dependencies, and our project needs to know what those are. The way to add a dependency like this, Express is the first one. We'll be adding more. The way to add it is running the command npm install and the name of the dependency, which here is Express. So if I run npm install Express, it should install Express for me in this project, and it should most probably change package.json as well. So if you look at package.json now, it has a dependencies section and there is Express right here. This is a way for you to store the structure of your application or all the dependencies in a single place, package.json being that file. It also created this package-lock.json file, which we won't worry about right now. But package.json now has one dependency. We will be adding more, but I think this should be enough for us to start our project. So if I now run node index.js and I go to localhost :3000, I see hello world. Okay. So basically in 11 lines of code, you can write an HTTP server. Now a lot of things are missing here. Implementation is pretty much nothing. We have not deployed this on the internet, and this URL might feel weird to you. Why are we going to this localhost :3000? I want to go to helloworldapp.com. So when you're running apps locally, this is how you develop. You usually run apps on localhost. You don't always run it on some internet facing domain name like chat.openai.com or facebook.com. Eventually, it's very easy to deploy this on the internet and give it a URL. We're not worrying about that right now. So for the purpose of this tutorial, and generally when you're doing local development, your app will be hosted here. If I change this port to 3001 and I restart the process by typing node index.js, this will no longer return anything. And if I go to 3001, it will. The route is slash. So if you go to the slash route or don't give anything, it's basically the same thing. So localhost :3001 slash gives you this. And if I change the route, let's call it route 1, node index.js, now 3001 gives you nothing. If I go to slash route 1, it gives me hello world. Let's add another route, copy this code, paste it here. Let's call it route 2 and let's return hello world from route 2 here. Let's restart the app, and route 1 returns you hello world and route 2 returns you hello world from route 2. So as you can see, I can add more and more routes. We still have to add structure to it, but this is enough to create an HTTP server. If I return HTML from here, you will actually see a page rendered. Do you want to try that? Let's try that. What is chat GPT's route? It's the slash chat route. So let's do app.get slash chat rest.send HTML. I worry this might not work, but let's see. There you go. It did work. So I sent some HTML. Now for people who don't know HTML, you need to do a tutorial of HTML before you understand this. But basically HTML is usually written in HTML files, and this might feel weird. Why are we writing HTML in a JavaScript file? But bear with me for a while. What I did here was I can actually change the color of this as well. Style equal to color red, and let me restart, and there you go. Now the slash chat route is actually returning HTML. So your HTTP route can actually return back HTML, as you will just see here. The localhost colon 3001/chat returns bunch of HTML, and /route1, if you might remember, returns simple text. The other important thing to usually send in applications is JSON, which is basically an object that looks like this. Let's send this. And if I go to route 2 now, as you can see, it's a black page because no longer is HTML or text coming back. What's coming back is this JSON. If I go to preview, I can actually see. And this is usually how data is structured from the backend. When you in LeetCode ask the backend server for, hey, give me all my submissions, it will most probably return you a JSON object like this. On chat.openai.com, as I showed you, there is a request that goes out to get all of these existing conversations. And if you look at how the data comes back from there, it is a JSON object. It might feel complicated. There are arrays inside the JSON, but a JSON can be a very complicated object, can have nested children, it can have arrays, so on and so forth. So now we are able to send back data. The only thing that's missing here is sending headers from the client. We are not yet sending headers. We're also not yet sending query params, and the backend sending back headers or status codes. That's important. Let's quickly do that. So let's say there is a route in the backend of your application. Let's actually change these to some friendly routes. Sign up, login, and questions. So LeetCode has a bunch of questions. This endpoint should return those. Another one should be submissions. I've created 4 stubbed routes here that right now basically do nothing. The first one is the route that you should hit when someone tries to sign up. The second one is the route that you should hit when someone tries to log in. Third one is the route that you should hit when someone tries to get questions from the backend. And in LeetCode, there are a bunch of questions. If you open the LeetCode first page, you'll see a bunch of questions. So it should return an array of questions, and submissions should take in as an input the question that you're asking the submissions for. So if you've made 5 submissions to a problem, let's say 2 states is the problem, your request should send from the client, should send out the ID of that problem, and your server should return back an array of submissions, your existing submissions, and maybe the status codes, whether they were accepted or not. Cool. So I am leaving this here. I think this has become a very long video already. So what we'll do now, I will leave a few things here as an assignment. The first thing you have to do is add an object store here. What is an object store? So as I told you initially, there are databases, right? And usually you store data in databases, but that will be a little hard right now. We don't want to yet get into SQL databases. So for the purpose of the assignment, and I'm getting into it right now, basically the tutorial is done. This is how you create an HTTP server. Now you have to create an HTTP server that will, one, let users sign up. So when the sign up route is hit, the user should be able to send some data. Also, sign up should be post and not get. Login should be post and not get. And these two should be gets, because you're trying to post data during sign up, and in get, you're just trying to get data. So I'm going to add a bunch of comments here. Add logic to decode body. Body should have user email and password. Basically same thing here. Once you've done that, store email and password as is for now in the users array above. Only if the user with the given email doesn't exist, and then return back 200 status code to the client. Here in the login endpoint, you need to basically add the logic to decode both the things again. Then check if the user given email exists in the users array. Also ensure that the password is the same. If the password is the same, return 200 status back to the cloud. Also send back a token. Any random string will do for now. Wow, this AI is too good. If it's not the same, then return back 401 status code. So write the logic for that. And then in the questions array, for now, hard code the questions here. For example, questions could look something like this. Given an array, return the maximum of the array. There should be more things here other than title description. Maybe a test cases should be an array and should look something like this. Input 1 2 3 4 5, and output should be 5. This is one test case. You can add more. So this is the structure of one question. You can add multiple questions. You can hard code them for now here. And the /questions get endpoint should pretty much just return the user all the questions in the questions array, and the submission one, the get submission, should return the user's submissions for this problem. There should also be a post to /submissions, which should let the user submit a problem randomly, AC, or accept or reject the solution. Store the submission in the submission array above. So let's create a submission array. You can basically keep the shape of this object to be whatever you want. So for example, this AI is so good. It basically returned me this shape, which looks good. So you don't have to hard code it here. Whenever someone sends, it should be an empty array initially. And then when people post a submission, it should get stored in this submissions array. And then eventually when people get a submission for their problem, they should get it from the same array. I can guarantee you ChatGPT can write this. If I give it this prompt and I say, can you complete this function? I'm 100% sure it can complete it. So you have your own tutor now. I have created this boilerplate code. There will be different ways to tackle it, especially like the submissions array shape here might be different. But other than that, the users array also might be different. But other than that, it will be fairly straightforward for you to create these 6 endpoints, which should be enough to create the authentication system for LeetCode and the problem layer for LeetCode. You can also add a few more routes here if you want, leaving as hard to do's. Create a route that lets an admin add a new problem. Ensure that only admins can do that. So when you're signing up, you basically have to give the user an option to either be an admin or a normal user, and admins should be able to change this questions array. So for V1, hard code all the questions. For V2, let the admins add questions as well. And then you have to make sure you're authenticating the admin correctly. So you'll have to understand middlewares and a bunch of other things. One important detail, we're not using databases yet. So if you start your application and then people create submissions and then fetch their submissions, if you turn off your application and turn it back on, all the data will be gone because we are not yet persisting data into databases. That can also be a decent assignment. I will do that in the next exercise, the third one, actually creating database records and everything. But for now, feel free to use an in-memory object where you store data and just assume that your application will be alive forever. And this should be a decent starting point for you to create an HTTP server for this specific application. Now applications change and the whole worry around AI taking our jobs. The thing is, only this structure needs to be defined by a human, and eventually maybe not even that. And then a lot of writing the code is actually repeatable tasks that actually can be done by an AI, should be done by an AI. You should understand them though. So that is what I would suggest in this video. I think if you just copy this whole thing and paste this whole thing into ChatGPT, it will give you a response. But I would suggest you go step by step and ask it, hey, what is the right way to sign up? Hey, what's the right way to sign in and send back an authentication tokens? What are the authentication tokens that are used in the industry? How do I make sure that the authentication user is sent back to the user? They store it in the browser and then send back in every subsequent request. How do I make sure when the user clicks on the logout button, then the authentication token on their browser gets cleared? So these are smart questions to ask and figure out the rest of this yourself. If you cannot, let me know in the comments. I will create a detailed video. But I think this is a good point for me to just throw out my knowledge out there and tell you how things are done. HTTP servers written in the industry, very similar. They are better structured into multiple files. Usually TypeScript is used and not JavaScript, and real databases are used. But other than that, all HTTP servers usually look like this. They have such a shape and only application details are different. But this is the right way to create the first step of a MERN application, which is the backend. And I would suggest you complete this. This is on GitHub. Complete this and create a pull request. I might not merge it. I cannot merge all the pull requests, but this will be a great first point for you to start writing code and also understanding how to contribute and submit it to GitHub. So in the description, there is a link to this project. You can simply clone the project and complete it. Or if you want to start from scratch, you can do that as well and push it to your GitHub. I am extremely excited. In the next video also, I will be creating such a prompt or like a structure for the application and expecting you to complete it and create a pull request for it. I think this is the best way to learn. If I complete the whole thing, it's no different than any tutorial out there where you understand how something is done, you copy paste the code or like do it with the person who's teaching, and then you can't build an application of your own. These are good comments I've left. I think these are enough for you to understand what needs to be done, and hopefully many of you should be able to complete it. I think I'm not going too fast, but if I am, let me know and I can slow the pace and teach a little bit more. But the overall idea is most applications, everything you see on the internet, Instagram, Facebook, is run by HTTP servers in the backend. Your browser sends HTTP requests. The HTTP request structure looks something like this, and this is a way to create HTTP servers in Express or Node.js. Now, what are the next steps from here? It's deploying it on the internet, buying domain names, hosting them somewhere. But this is the gist of the most difficult part. Everything else is fairly simple to understand. Here is where you need to write the code. And as you might see here, it's actually not too difficult. Basically, in 73 lines, you can create the skeleton of your app. And I think in around 200 lines, you should be able to complete the whole application. So all the best. Hopefully you create a bunch of pull requests. I am looking forward to those. With that, let's end the video. I will see you guys in the next one. Bye.